All right, let's get started. PS6 is out and due Thursday, and then fall break. After fall break, there'll be a midterm. So the week after fall break, we'll do a review on Monday during lecture, and a review in the lab on the following Tuesday, which will be, we'll go over the sample midterm that I posted. And then Tuesday evening at 5:15 in here, Stefan will be doing a review. And then we have the midterm itself on Wednesday after fall break. Any questions or problems about anything before we proceed? Okay. We're going to do something new today. Since the beginning of the semester, we've been working pretty hard on statements, really, methods and statements. And one thing that we've learned is that one thing programmers do is they make parts. And one kind of part that they make are new methods, particularly new static methods, is what we've been looking at. But another kind of part that you use for your programs all the time are objects. So what we're going to start looking at today is how you as a programmer can create new kinds of objects to use in your programs. So whereas before we were just extending the number of actions that we had to us, now we're going to extend the variety of objects that we have available to us. So you can make custom objects, and that makes building large programs easier. Before we talk about how to do that, let's talk about, this is related, static members of classes, which is pretty much what we've been doing up to now. And you know that there can be constants in a class. So this first declaration here, public final static double pi, that declares a constant, pi, that can be used throughout the program. So it's just a symbolic constant. You also know, this last one here, that you can put static methods in the classes. So that's a static method that takes a parameter and returns a square. And you can also create, I see a typo I made there, it should say public static double x. That should be a static variable, I'll fix that later. You can have static variables, not just static constants. But where most of you where almost all of you are right now, I would strongly recommend you stay away from ever using a static variable. Because 99% of the time when you decide you want to use a static variable, it's a mistake. Let me explain what a static variable is. It's just just as you can do, well, let's go to the next slide here. Just as you can refer to demo.py, and that's a constant, and you can refer to demo.f, and that's a method, you can refer to demo.x, and that's a variable. Now, where would that variable be visible? Assuming I declared it correctly and actually said public static double x. Yeah?
It'd be visible to anything in the class or anything accessing that class?
Yeah, he said it'd be variable. You could use that x anywhere in the class. And you could also use it, you could just call it x. From any method in the class, you could refer to it as x. And for anywhere in the program, as long as you have access to the method, to the class, you can say demo.x. And it'd be the same variable everywhere. So what could possibly go wrong with that? Having a variable that you can use from anywhere in the program. Yeah?
You can't call it from outside the class?
No, you can use it from outside the class.
We're talking about public static variables, right?
Mm-hmm. Public static variables. So right here, as long as we say demo.x, we could use it anywhere. Yeah?
If you make a more global one, then if you try to make one inside like local variable, it might get confused.
Okay, so the key thing that you said was it might get confused or might get confusing. Do this thought experiment. Imagine you have a bunch of static methods in your class, and they all have an index variable called I. Each of them declares their own I. Int I equals 0, and then you have a loop that increments it. And suppose you say, I'm tired of declaring variables. I'm going to not declare any of these variables, and I'm just going to declare I as a static variable, accessible to all the methods. So now every one of those methods is sharing the same I, which means if you have a loop that's incrementing I and it calls a method that also has a loop, you call a method from inside the loop and it calls a different method that modifies I, the loop back here is screwed up. It's bad news when you've got these variables that can be modified from anywhere. You can't count on what's going to be in them anymore. So bottom line, don't use static variables, at least for now. There are cases where they're appropriate, but the number of times I've seen students misuse them just dwarfs the number of correct usages. So if you declare a static variable, make sure it's final. Okay, you can also declare things that aren't static, and that's what we've been staying away from until now. You can declare what are called instance variables. So here so notice the keyword static is missing everywhere. I didn't say private static double latitude. Latitude is a private instance variable, and we'll see what that means. Longitude is a private instance variable. We're in a class called coord. It's meant to represent coordinates on the surface of the Earth. Another non-static thing you can do is create a constructor, and so that's a constructor right there, an example constructor. And we got to understand what that's all about. But just look at it right now and tell me what's different from that and a method. It looks a lot like a method. You see anything unusual about that? Yeah? There's no return type. So it doesn't say public void coord or public int coord. There's no return type. So that's a big clue that that's a constructor. There's one other thing about it that you may think is a coincidence, but it actually isn't. That really nails down that it's a constructor. Yeah?
The name of the class is the same.
Right, the name of the thing that looks like a method is the same as the name of the class. So if something looks like a method, but it has no return type, and the name of the thing is the same as the name of the class, we call it a constructor. And I'll explain what that is later. Okay, so far we've got instance variables, which are just non-static variables, and constructors. And then you can have methods. So here are a couple of methods. They're not declared static. They're just methods that belong to the class. Okay, so that's just a preview. Now we're going to go and look at how this class here, so we take this class, which starts on this slide and ends on that slide. It defines, that class defines a new kind of object called coord. So it lets you create coord objects and lets you call methods on coord objects. So let's see how it works. How does this allow us to do that? Oops. This is just what I said. The instance variables, the constructors, and the non-static methods together cooperate to define a new type of data. So when you use array lists or strings or whatever, behind that is some class that has constructors and methods and instance variables that let you do what you need to do. Okay, so at the top here, I've got a definition. That's just the class we just looked at, the coord class. And it has the instance variables, the constructor, and the methods. Just in the interest of space, I don't have the implementations of the constructor or the methods. And down here is an example, some examples of what you can do if that class, if you had that class. So you can see what you can do is you can create a new coordinate object right there, where it says new coordinate. You've done that sort of thing before. You say new scanner, you say new, you don't really say new string, new random, whatever. So this says create a new coordinate from these parameters. And we take this creates a reference to a coordinate object, coord object, and stores it in C1. Same thing right here. We create another coordinate object and store it in C2. Once you've done that, you can call methods. So you can say C1.getLatitude, because getLatitude is a method provided by the class. Or you can say C2.toString, because toString is a method. So once you have that class, suddenly you have coordinates. Okay, now I'm going to go through the definitions and the uses and try to connect between the two, show you how it works. So you can see what's highlighted in yellow there. What is it about the class up there that allows you to declare variables of type coord? So forget about all the stuff out here. Just focus on coord C1. What is it about the definition that lets you, gives you a new type name to declare variables with? Yeah.
You have a class called coord.
That's it. He said you have a class called coord. So if you could take everything out from the braces, just say class coord brace. No instance variables, no constructors, no methods. You would still be able to declare variables of type coord. Now it wouldn't be very useful, but you could. So when you create a class like that, it introduces a new type name for you to use in your program. Yeah.
So a constructor is not required for an object?
Constructors aren't required, no. This particular example wouldn't work. You'd have to, we'll see what I mean by that about not having a constructor. So being able to declare a variable has nothing to do with what's in the class. It's just what's the class's name. The class's name, every class's name is a new type name that you can use. That's where types come from, reference types come from. Okay? Now, here are the instance variables. There are two instance variables, and they become important, they first become important, when you create a new coordinate object. So, up there are two instance variables. Down here, we're saying, give me a new coordinate object. And that takes several steps, so I'm going to show you what the steps are. So there's our, there's the relevant part of the class right now. We're trying to look at the title says we're creating a new coordinate. And the way I want you to think about this process I'm about to show you is imagine you have a rubber stamp. So you can take the stamp, ink it up, and make a mark on paper. That's what I want you to think of new doing. Okay? We'll see what I mean. When you say new coordinate, what Java does is it says, okay, what are the instance variables of this class coordinate? And it creates an object, which is all the object is. It's a place in memory that can hold the values of the instance variables. So essentially, when you say new, imagine this rubber stamp had that white box thing, the latitude longitude box on it. Every time you call new, you stamp out a new object. We stamp out an object in memory. We stamp out an object. We stamp out an object. You call new 4 times, you've created 4 objects in memory. The size of the object is determined by the number of the instance variables and the types of the instance variables. But every time it's stamped out, you get a spot in memory, a place in memory, where you can store both the latitude and the longitude. If there were a 3rd instance variable in here, like altitude, then there'd be 3 places in the object to hold those values. That's all an object is. Place to hold instance variables. Okay? So that means that when you look at these variables right here, you can't think about them in the same way you would if they were declared static. Let's think about that. If these were static variables, we would say, okay, there is 1 latitude variable associated with the class and 1 longitude variable associated with the class. But what does it mean when they're not static, when they're instance variables? What does the word instance suggest? Yeah? Okay, he said they're unique to the instance of the class. But what's an instance of the class? Okay, so an object is an instance. So until you create a coord object, none of these variables exist. So the variables don't exist independent of objects or outside of objects. They're just there so that when you create, when you ask to have a new object, it's created for you, and room is reserved in the object to store the values of the instance variables. Now I'm going to go to Eclipse for a second and show you something. Okay, this is a main method, and it creates a string, a scanner, and a random number generator. And I'm going to put a breakpoint right here, and then I'm going to run a debug mode, and it's going to enter debug mode, and then let me show you what I did. Okay, up here, the variables are text, well, args, text, scan, and rand. They're just the variables from right here, the variable that we created. I'm going to zoom in here so you can see it on the screen. I want to look at those values at text. So text, scan, and rand are each an object of different types. Okay, so we can still see these things up here. So let's look inside of rand. What do you think you'll find if we crack open rand, that rand object? Well, what if this were a chord object and we cracked it open? What would we find inside? Yeah?
Latitude and longitude.
You'd find latitude and longitude. So what I'm going to find when I look into that rand object is whatever the instance variables of rand are. All right, so let's expand it. And you can see it has an instance variable called seed, which controls how the random number generator works. And then it has have next Gaussian, and next Gaussian. Not sure what they mean. That's what's contained by the object. What if we look inside the scanner? What do you think we'll find? Wow, lots of stuff. Buff, close, decimal pattern, decimal separator, default radix, digits, blah, blah, blah. Look at all that stuff. You had no idea, probably. There's a lot of detail contained in a scanner object. It's got to keep track of what it's reading, where it is right now, how it's defining delimiters, is it closed, so on. If we look inside of a string, we find coder, hash, whatever they are, and value is an array of chars, and if I weren't zoomed in so far, we could see what the values of those things are. So any object is going to contain space to store the values of instance variables. Now, you've been using strings, you've been using scanners, you've been using random number generators, but you never knew what the instance variables were. That's an important lesson. Do you need to know what the instance variables are in order to use an object? Not at all. You're all examples of that. I haven't said boo about what the instance variables are until now. You don't need to know that stuff. You just need to know, how do you create one, and what methods can you invoke on it, what those methods do. So the instance variables are of interest to the innards of the class. They're not relevant at all to someone standing outside the class asking, how does this work? So let's go back to the slide. So yeah, if your job is implementing the core class, yeah, you worry about what are the instance variables. But notice they're private. Private signifies that they're not of interest to someone outside the class. They're only interested to the programmers implementing the class. Okay, so that stamps out our, when we say new core, that stamps a spot in memory and gives us back a reference. These arrows here are references. Gives us back the address in memory where the object was placed. What do you think is the next step in creating an object? Are we done? You say new coord and the object is, yeah? He said we need a constructor. We need to put something in those blanks, right? We need to to put particular values for the latitude and longitude to actually have an object that represents a coordinate. Because right now those variables are uninitialized. And that's what constructors do. So after you have created the object in memory, the constructor runs. And what the constructor does, it can do lots of things, but its primary responsibility is to initialize the object properly. So the constructor runs after new has done its thing and created an object in memory. So let's zoom in and see what the constructor does. So there's our constructor, and it says latitude equals lat, longitude gets lon. Okay? Well, there are parameters to the constructor. Where would the values for lat and lon come from? In the back there. Okay. Right. So what he said was, you know, the user is calling the constructor. So there's 40.28383 minus 11.38922. That's being passed, just like you're calling a method. Those values are passed to the constructor. So those two numbers are lat and lon. So in that respect, it's a lot like a method call. Yeah?
So if you did not have that constructor there, you would not be able to pass anything in.
Right. If I did not have this constructor here, I could not, right, I couldn't do this.
Right. Okay.
To do this, there has to be a 2-parameter constructor that takes 2 doubles. Okay? So you see what that is. You know what lat and lon are. Those are parameters passed in the new expression. Okay? And you see them here. But what are latitude and longitude? I don't see them declared here.
Yeah, I don't know about
What are they?
Those are the instances.
Those are the instance variables. So this isn't the entire class, remember. There's those 2 private instance variables declared, latitude and longitude. So what's happening is this. We call the constructor, and what the constructor is operating is this uninitialized object. And what it does is it does this thing. It says, okay, the constructor has a reference. When the constructor is called, it'll have a reference to this structure here. So it'll just say, okay, first thing I should do is take my parameter lat and store it as in the latitude spot in the object. And then it executes the next line of code, which takes this parameter and stores its value into the longitude slot of the object. And that's what a constructor does. This constructor is just filling out the object. Yeah?
So, where's it defined that the latitude spot is right there and the longitude spot is right there?
Where is it defined?
Yeah.
That's probably, okay, so the question is, how did the constructor know to put the latitude in this box and the longitude in that box instead of the other way around? Now there's a fiction going on here. In reality, this information is not stored in the object. That's there for us so we can read it more easily. In reality, it doesn't say latitude and longitude. The code just has to know that the latitude is stored in the first spot and the longitude is stored in the second spot. And how that happens is up to the compiler. When the code is translated closer to machine code, the compiler decides whether latitude or longitude will be first, and it just remembers that in all the code that it produces. Okay? So, pretty simple. Remember, the constructor is given a reference to the object to initialize. And the object it's given is, well, not too far. The object it's given is the one that was created by this new coord thing. So we first create the blank, and we fill it out. That's a constructor. And then we store that reference into C1. Now C1 contains a reference to an object. Yes?
So this, well, so what you're saying about where the latitude equals lat and longitude equals lon, is that just, I'm still not really sure I understand if that's pseudocode?
No, this is not pseudocode. These are just 2 assignment statements. It says take the value of lat, which is a parameter, and store it into the latitude field of the object.
Oh, and if you've already initialized those, then where are they? If you've already initialized
Well,
latitude and longitude.
what we started with was that. We started with a reference to an object that needed to be initialized. And this first assignment says take lat and store it in latitude. And latitude is this box right here.
But if
Yeah.
you just typed in, if you had already had double lat and double lon, and you just typed in latitude equals lat, Java wouldn't accept that. It would say that latitude wasn't declared properly.
Well, okay, so the objection here is latitude is not declared properly. Remember, you'd be absolutely correct if this were the whole class. But remember what the class is actually that. Latitude and longitude are declared. And then there's the constructor. So we just zoomed in. So,
Okay, I didn't understand that those were part of the same thing.
yeah, all these things, the instance variables, the constructors, and the methods cooperate to create to define objects. Okay, so there's C1. Now what happens when we do that? Is it going to go and overwrite these values right here? Because it looks to me like it's going to set latitude to a different lat and longitude to a different lon. What's going to happen here? Yeah? Right. So what he's saying is, here we created a new object and then we initialized it. Here we're creating a different new object and we initialize it. So when you look at the constructor, latitude and longitude refer to instance variables. They don't refer to specific variables. It depends which object's being initialized. And then you got C2. So now we've got two independent objects with different latitudes and longitudes. The same constructor initialized them. Every time you call new, you get a new chunk of memory. That chunk contains space for the instance variables to be stored. That brings us now to methods. So look at this, the third line down here under use, and you can see that I'm doing C1.getLatitude. The question is, what happens when that runs? Okay, so we're invoking the getLatitude method, which is highlighted in yellow here, on the object C1, which we just created up here. So let's go look. So here's where we are. In memory, we have C1 and C2. We're doing C1.getLatitude. And what getLatitude does, you see the code up there, it just returns latitude. But which latitude does it return? There's that one, there's that one, and if we've been busy, there could be a million more. How does that poor method know which latitude to return? Yeah.
You're calling it on C1?
Okay, he said we're calling it on C1, and that's crucial. C1, well, let me just say this. The keyword this it's a Java keyword. It's accessible when you call a method. The method has access to the current value of this. Okay? And in this case, when getLatitude looks up the value of this, it will be this object right here, because this is always the object on which the method was invoked. So when you invoke a method and you get inside that method, this, you can think of it as a constant variable, this is set to the object on which the method is invoked. So this and C1 point to the same place. Okay? It's often called the implicit parameter. So this is called the implicit parameter. It is a parameter to get latitude, but doesn't show up in the list of parameters. The parameter list is empty. Every method of a class, every non-static method, takes this as a parameter. The method, it takes the object on which the method was invoked as a parameter. It has access to the implicit parameter. This makes sense as we go through more examples, but it takes some getting used to. Now, there will be a question on the final. The question will be of the form, what is this? The answer is the object on which the method was invoked. This is the object on which the method was invoked. That should be your mantra. It answers a lot of questions. Here's one question. Where do we look for latitude when this method runs? In which object do we look for latitude when that method is run? Yeah?
Just C1.
In general. It's 8 words long. Yeah?
The object on which the method was invoked.
Right. We look for latitude in the object on which the method was invoked. Okay? So, in fact, that up there, return latitude, is actually an abbreviation for something more complex. That's the full form. So you could write it that way. You could say return this dot latitude. And then it's clear that when we're talking about latitude, we're talking about the latitude field of this object. And this object is the object on which the method was invoked. So since we're calling get latitude on C1, what's this method going to return? Yeah? 40.28383. Because that's the latitude that belongs to the object on which the method was invoked. Yeah?
So in this specific example, it seems like the presence or absence of this right there doesn't really matter. Where's an example where it would matter?
Okay, so he's saying, he's observing, okay, this dot latitude in this case means the same thing as just latitude. You could, we could write this dot latitude until we got sick of it and then start writing latitude. You just got to understand that when you see an instance variable in a method, it's actually an abbreviation for this dot, that instance variable. Okay? And you hardly ever see it written like that. The times that you do, sometimes the only time it's necessary is when there's some other variable called latitude, and you need to distinguish between a parameter called latitude, say, and the instance variable latitude. So you say this dot latitude is, say you're talking about an instance variable. But we won't see that for a while. Okay? So think of instance variables that way. Now, okay, that's what it looks like when we call C1. When we call C2 dot get latitude, now this refers to this object. Why does this refer to this object? Yeah?
The object on which the method was invoked.
Okay. Because that's the object on which the method was invoked. That's what this is. It's got to refer to the object on which the method was invoked. And so now, when get latitude is called, what is this dot latitude going to be? Is it going to be 40.28383? Yeah? It's going to be 80.87117. So the method always operates on the object on which the method was invoked. And it's confusing to people because they don't see this as a parameter right there. Because it's the implicit parameter. Every non-static method takes this as a parameter, but the way you pass the parameter is not by putting in parentheses. How did we pass C2 to get latitude? How did it become this? How did we say, I want you to operate on C2, not C1? Yeah? Right. We say C2 dot get latitude. And that means we're calling the get latitude method. C2 is this now. Whatever C2 refers to is what this is going to be. And there are no other parameters at this point. So that's where this comes from. It's just the object in which the method was invoked. And when instance variables appear in a method, they are interpreted relative to this. So that's what happens when you call a non-static method. Now we're going to work through a series of classes and see what it's like to implement a class. Get away from the theory here and look at the practice. Before I do that, are there any last questions I could answer about? Yes?
So yeah, I'm just still kind of confused on why we would need like this dot latitude if we invoke like C2 or C1 dot get latitude inside of this method, I guess.
So you're wondering why don't we always just say latitude instead of this dot latitude?
Yeah, since it's,
With the understanding that when we say latitude, we really mean this dot latitude.
yeah.
Yeah, that's a hard question. Until I can show you an example, let's not worry about it. When you actually see an example, it'll make perfect sense. Yeah?
If we wanted to call a method on whatever, so like if we had a method that we wanted to call inside of getLatitude, would that be an appropriate place to use like this dot another method or something like that?
Okay, so there's a method called toString in this class. So suppose for some reason inside getLatitude we wanted to call toString. So we could say this dot toString, in which case we're saying call toString on this. But we could just say, we could just call toString, because that's also an abbreviation for this dot toString. So any instance variable or method that you refer to inside another method, implicitly, unless you say otherwise, you're implicitly calling it on this. You're implicitly invoking it on the object on which the method was invoked. Yeah?
If we declare our variable as public, could we access, for example, latitude outside of the class by just typing C1.latitude?
Okay, so the question was, let me go back to where we actually have a declaration. There. Suppose I declared instance variables public. Then, yes, I could say, down here under use, I could say C1.latitude, C2.longitude. However, it is really, really important. Instance variables should never be public. Now, once a semester, I climb up on the table and say something, because you'll never forget. Instance variables should never be public. Okay? It's a good way to lose points on an assignment. It's a good way to lose points on an exam. Instance variables should never be public. We could talk about why later, but it's easier just to give you the rule. It's a bad idea. Yes?
If instance variables should be public, then when should variables be public?
Okay, when should variables be public? Instance variables should never be public. Static variables can be public when they're constants. So static constants could be public. Instance variables should always be private, never public. Any other questions? Yep.
Things that private and public and static are things we tend to associate more with methods than with variables. So what does it mean if a variable is a stat? If you define a variable as static, what does that do to it? Does that mean it's constant?
Okay, so she's asking about static variables. A static variable belongs to the class. When you declare a static variable, there's only one of them ever, and it's associated with the class. So it exists immediately upon declaring the class, and it's always there, and there's only one of them. Instance variables, non-static variables, are associated with objects. They're what is stored inside of objects. And initially, there aren't any in existence. When you as you create objects, you get instances of the variables. Yeah?
Can objects call methods on other objects?
Okay, the question was, can objects call methods on other objects? I think the question should be, can non-static methods call other methods?
Yeah.
Sure. Yeah, the stuff that goes inside of methods, non-static methods, is the same as the stuff that goes inside static methods that you're used to. The only difference is, in a non-static method, you also have access to the object on which the method was invoked. You have access to this. That's implicit. Yeah?
Do static method calls also have a this variable?
No, with statics, there's no this.
Question?
The question was, do static methods also have access to something to this? And no. Because when you call a static method, you don't say object.static method. You say class.static method. So there is no this for a static method. Yeah?
So if you were to write a static method and use this, would it still be a keyword inside the static method?
If you use this inside a static method, you get a compiler error. Yeah?
So if you're not using a static method, do you need to have something, an implicit parameter for it?
If you're...
If you're not calling a static method, do you need to have an implicit parameter for that?
Yeah, when you call, so the question is, if you're calling a non-static method, does there have to be an implicit parameter? Yes. And it's the implicit parameter, when you call a non-static method, you're always invoking it on an object. You're always doing, and so that object you're invoking it on is the implicit parameter. Okay, let's take a few minutes and we'll do some coding. All right, let's get started again. Have a question?
Yes. What is the difference between default and instance variables?
Between default and instance variables?
Yes.
So,
is there a difference?
I don't know what a when you say default,
Well,
what
I
do you
mean,
mean?
when I say default, I mean without any modifier, without public or private modifier.
Oh, okay. So he's asking about instance variables. You know, you can declare them public or private or protected, or you can leave it off. We're just worried about public and private for now. So really your question is what happens if you don't say whether it's public or private?
Yeah.
I believe what it means then is it's by default it's visible anywhere in the package. But I never leave it off, so I don't know that for sure. All right, so here we are. Over on the left, if you can read it, I've defined 5 classes, Coord 1 through Coord 5. And I'm starting with very simple and working up to something more functional. Let's look right here. At a minimum, when we look at Coord 1, the code for Coord 1, at a minimum, what will that class have to consist of in order for those declarations to be legal? Yeah?
Like a name and then like braces?
Okay, so there's going to have to be a class called Coord 1. So the class will have that name. So it'll say class Coord 1. And it'll have to have braces. That's what classes have to have. What goes inside those braces? Yeah? Say a little louder. Well,
what did you say?
He said non-static methods. But you don't see, I'm not really using any methods here, so I'm not, at a minimum, I don't have to have any methods because I'm not using any. Yeah?
Instance variables?
Instance variables, maybe. Yeah? Okay, so he's talking about constructors. So it looks like I need a 0 argument constructor, right? And here's the answer. That's as simple as a class gets. I'm just saying public class Coord 1, empty body. So we're defining no methods. We are including no instance variables. There's not even a 0 argument constructor. Because if you do not provide a constructor, Java will provide one for you. And that constructor will take no parameters and do nothing. Okay? Because what could it do? So this is not a very useful class. It's hard to say this represents coordinates because it knows nothing about latitudes and longitudes. But that's the minimum necessary. So you can declare a class like that, and then once you have a class like that, you can create new objects. But there's not much you can do with those objects. Now, you might be surprised. There's actually something you can do. And you can see it if I say P1 dot. And there we go. It says there's an equals method, a get class method, a hash code method, notify all, 2string, and 3 methods called wait. Where did they come from? It looks like this class was born with methods. Yeah?
The object class?
Okay, he said the object class, which is correct. But I don't want to get into those details just yet. Basically, every class by default has these 8 or 9 methods. Now, most of them aren't going to be very useful. 2string is probably the most interesting one. So you get a default implementation of 2string, which converts the class into a string, an object into a string. And you get a default implementation of equals that behaves just like double equals. Okay? Now, this display method right here, let's go look at it. What display does is it prints out point 1, it prints out the object, it prints out the other object, and then it prints a blank line. So let's see what's printed by, remember, and let me go back. How is PT1, which is a coordinate object, going to be converted to a string? How is any object converted to a string? Yeah. He said it's empty, so it'll just be null, but actually, there's a different answer. When you print out an array list, what turns that into a string? When you print out a random number generator, what turns that into a string? Why do you think every class has a 2string method?
What?
Why does every class have a 2string method? Why did the designers of Java decide every class needed a 2string method?
How does every class have a 2string method?
Yeah.
So you can represent the object as a string instead
So
of just...
okay, so he said, so you can represent the object as a string, so you can convert the object to a string. whenever you say print out this object, it automatically calls the toString method. So what I have there is equivalent to that. Okay? When Java needs to convert an object to a string, it calls the toString method. So let's run this and see what it prints out. We're just interested in that. So this is what I printed out for point 1 and point 2. What do you suppose that is? Coords.coord1 at 6bdf28bb. That's what the default implementation does of a toString method. It gives the complete class name, which is the package, class name, and then what do you suppose that is? Yeah? It's not, it's, well, it actually, in a sense, it is the hash value, but yeah.
Is it the location in memory?
It's the location in memory of the object. Okay? That way, every object by default has a unique string it prints to. Now, that's not very useful. You know, you don't want to show that to the user, but it just guarantees there's some way to print every object. Incidentally, that's what happens when you print a string. This is what happens when you print a scanner. Okay? Now, why does a scanner look like that when it gets printed? Why doesn't it look like java.util.scanner at and then some address in memory? Okay?
Because that's what they defined it.
Right. The scanner has, you can give an implementation of toString that replaces the default one. Scanner did so. And it's just sort of describing the state of the scanner. Now, I saw a lot of students that have been trying to use that toString method thinking it would extract all the characters from the scanner and you get a string. But your program didn't work when you did that because what toString does on the scanner has nothing to do with what's being scanned. It just has a bunch of really useless information there. Notice that the random number object, the random class, does not provide a different implementation of toString. It prints out the default way. Okay, Coord1, not so interesting. It's sort of the minimum you could have. Let's go and look at a different version. So this is Coord2, where I make a mistake. I make them public, and you should never make instance variables public. Okay? So let's look at main. Now, if we declared it that way, then let's go up here. We could, again, we would construct a Coord2 object by calling the default constructor that you get for free when I lost my train of thought there. You get for free when you don't provide a constructor of your own. But what does that constructor do? I already told you what it did. What does it do? It's the default constructor you get for free. It's one word, starts with an N and ends with nothing. Okay? It does nothing. That's a slight lie, but for right now it does nothing. So that means it can't, it's the default one, the default constructor doesn't initialize the instance variables. So since they're public, we could store 17 in the lat and 22 in the lon. Because I do have, notice I did declare instance variables, lat and lon. And then I could display them, and this is what happens. I'm printing out the lat, the lon, and the object itself. So anyway, this is an example of what not to do. We have, what I've done is I've made the instance variables public so I can initialize them. But what's the right way to initialize the instance variables? Yeah? With what? Well, that's maybe I could use a method to change the value, but where do the initial values of instance variables come from? Well, no, it's not an initializer, it's what?
Constructor?
A constructor. That's what constructors are for. We want to make the instance variables private so that the constructor and the methods have private access. No one else can muck around with the instance variables. So let's look at another version here. This is coordinate 3. They're still public, which is bad. But here's a constructor. So let's look and see what that constructor does. So it takes in a latitude and a longitude, a lat coord and a long coord, and ultimately it initializes the instance variables with them. What's going on up here? Yeah?
It's making sure the latitude and longitude are actually possible latitudes and longitudes.
Okay, yeah. It's making sure that the parameters are sensible. And it throws an exception if not. And so the constructor can throw an exception. If all the values check out, then we initialize lat and long. Now, suppose we call this thing lat instead of lat coord. What problem do we have all of a sudden? We name a parameter the same thing as the instance variable. Yeah?
Then when you call it, it doesn't know if you're calling the parameter or
Okay.
whenever you're mentioning it, it doesn't know if you're calling the parameter or the instance variable.
Okay, so the question then is, which lat are we talking about? Does lat here refer to that? Or does this really stand for this dot lat? And the same thing here. And the answer is, if you do this, then anytime you say lat in this method, you're referring to the parameter because it's defined closer. And if you hover the mouse over this thing, it says the assignment to variable lat has no effect because you're just assigning the value of the parameter to the parameter. What do you suppose we'd have to do to disambiguate things if you happen to have a parameter with the same name as the instance variable?
Replace the left side with this top.
Right, you would say this is the situation where you actually use the this keyword. You say this dot lat. So the lat instance variable takes on the value of the lat parameter. Now you might say, just don't do that. Don't name an instance variable, a parameter the same thing as an instance variable, and that's good advice. But I'll just tell you, sometimes it's hard enough to think of one good name.
Oh, yeah.
And I'll admit that so sometimes I do that. But. Okay, so there's our class. And that's good. We have a constructor now. So we don't get you only get a free default constructor if you don't provide any kind of constructor. So we can construct these things, and they have lat and long that we can access because they're public, but I've already said that's bad. So let's revise this class a little bit more. Now I've made them private. Okay, so when you're using an object now, when you have a coord 4 object, you cannot access lat and long from outside the class. So how are you going to find out the latitude and longitude that the coordinate holds? It's not very useful if you can just create it, but you can't ever find out what's stored in it. What do we need to do? Yeah?
We need to make some accessor methods.
Right, we need some methods. These are accessors. We have a getLatitude method that returns the value of the instance variable. And another one that returns the value of the longitude. So the instance variables are private. The methods get to look at the private variables and mediate between the users and the internals of the class. But the bottom line is that classes are difficult to implement correctly. They're difficult enough to implement correctly when the instance variables are private. If the instance variables can be public, you've got no control over those variables, and your job becomes impossible. Okay, what could we fix up about this class now? Right? We can create a coordinate. We can ask what's the latitude of this coordinate, what's the longitude of this coordinate. Can you think of any other method we might want to add? Yeah?
In the constructor, instead of throwing an exception because they're coordinates, you can take like the modulo operation of the coordinate.
Okay. So the suggestion is, instead of throwing an exception, we could, take the latitude mod 90, say, or something, try to fix up the parameters. And we could do that. But what other methods would be useful, do you think? Yeah? Way in the back? Okay, a two-string method would be nice because, you know, when we run our main method, let's go down to where we use coordinate 4, we're still getting this garbage back, right? We can access the latitude and longitude and print them out. But when we try to print out a coordinate, we're still getting the default thing. So what we need to do is go define a two-string method so that it'll print out like that. So what's it going to take to get a two-string method to, when we try to print out a coordinate, it'll print it out as square bracket, latitude, comma, longitude, square bracket. Instead of coords.coord at some hex number. Yeah?
You just use system.out.print.
No. Okay, he said we use system.out.print, but no, we're not printing. Two-string converts to a string.
Oh, sorry.
You then print the string, but the two-string doesn't print anything.
And you return it. We're just returning the string.
Yeah, we just need a method that converts latitude and longitude into this form right here. So that's coord 5. Private latitude, private longitude, the same old constructor, the same old latitude, the same old longitude, and now we give a two-string method. Now this override, we'll talk about that later, it's really optional. I don't want to confuse things, so I'll take that out. So the two-string method, what it does is it takes a square bracket, it appends it to the latitude, it appends comma space, it appends the longitude, it appends a closing square bracket, returns it, and that's what you see printed out down here. But where did this lat and long come from? Yeah.
Just the method defined above.
Well, no, lat and long didn't come from methods. Lat and long are instance variables, right? Right here. But there are lots of objects out there. Each object has its own lat and long. Which lat and long are we using here? Yeah.
Are they secret code for this dot lat and this dot long?
Sure. They're actually this dot lat and this dot long. So the lat and the long come from the object on which two-string was invoked. So whichever object you call two-string on, that's what the lat and long, which lat and long are being extracted. So that's why you see what's printed out down here. If we go back to main and look what was called, we said please print out point 1, please print out point 2. So it got automatically called two-string on point 1 and point 2, created those strings and printed them out. So that's the basics of an object, of a class. You provide a name of the class, that becomes a type name. You have private instance variables, which they are there to keep track of whatever the object needs to keep track of. And you have a constructor. You can have multiple constructors, just like you have multiple methods of the same name, but they're there to initialize the object. Then you have methods that let you do stuff with the object. Yeah?
I find it interesting that today your big point is that you should never make a
Instance variable public.
An instance variable public.
Mm-hmm.
But you know, when in the place where you made it private, it was number 4, I think. That kind of, you know, this particular class makes it look like it would be a good idea to make them public because adding a public double get latitude and public double get longitude just is redundant.
So, okay, so what she's observing is that it looks like it's kind of a pain to get longitude and get latitude methods when I just could make the instance variables public. Here's the problem. There are software engineering principles that it's good to know, and a good one to know is don't use static, non-constant static variables. Don't use public instance variables. It is hard to explain why those rules make sense until you start writing large programs, and we're not even close to writing large programs. When you're writing small programs, almost anything you do will be okay. But the problem with large programs is they get complex so quickly that you need to draw on the experience of people who came before you that discovered ways to make large programs that you can still understand. And one way that works, one key thing is keeping instance variables private. That's one key thing that makes it possible to work with large programs. So it's a little hard to explain right now.
I'm not saying I don't believe you, I'm just saying you're kind of like telling and not showing.
Yeah, that's exactly right. I'm telling and not showing, because what I need to show you is a large program. Okay, I'm going to look at another example here, because this was a very simple kind of class. I'm going to look at a more complicated one, but let me get a question first. Yeah?
So are like classes like Core 1, Core 2, Core 3, just like different ways of doing it? Just like
So with those 5 examples, I was building up from a very basic model that really did nothing to one that does pretty much what we need it to do. Now you could imagine adding other methods, but that works. Yeah?
So all of the Core 1, 2, and 5 and all those are different folders, but are different like space files, but would it be possible to create multiple classes inside the same file?
Okay, so it's asking, can you have, so there I have 5 classes and 5 files. Could I create one class, one file rather, that had 5 classes? Yes, but only one of them can be public. The rule in Java is the file, that .java file, coord5.java, must contain a public class called coord5. It can contain other classes, but they can't be public. All right, now let me tell you what I propose to do for our second class. Suppose array lists did not exist, and we wanted to create them. That would, you'd say that'd be very useful to have a class that was like an array, except things can grow and shrink. So let's think about doing that. Now my class, I have 2 versions. We'll start looking at the first one today. It's called MyList. And just to keep things simple, the only thing you can put in a MyList is an int. So what we're going to have are lists of ints that can grow and shrink. Now let's look and see what you can do. Let's go past the main is. There's a constructor. So there's a get method. So you can take a list and you can say, you can do list.get2, and it will return to you what's stored at index 2 of the list. There's a set method, lets you change what's stored at a given index of the list. So these names are inherited from array list. Add, you can add to the end of the list. Size, you can ask what's the size of the list. That's all we're going to do. I just want to be able to create a list using a constructor. So the constructor creates an empty list. Then once you have a list object, you can use get, set, add, and size on it. So it can't even shrink. All it's going to do is grow. So I've said here what the class ought to look like, what it's called, what the methods are, what the methods do. The first step in designing a class implementation is deciding what the instance variables ought to be. Very often that's the most important and creative thing you do as a programmer. And it can really affect the efficiency of your program. Choosing the correct way to represent objects. So how could we represent a MyList? When you cut open a MyList, what should we find inside? I mean, what does the representation have to do? What does it got to keep track of in order to answer all these questions you get asked of it? Yeah? Okay. So he said it has to know the values associated with the indexes. So as numbers are added to the list, it needs to keep track of those numbers. And it needs to know which was first, which was it added first, that'll be index 0. Which was index, that's index 1. So it's got to keep track of that. So would it work to have a single instance variable as an integer? That doesn't seem like that'd work, right? That's not enough to keep track of potentially, it could be 1 million elements in this list. Does that mean we need 1 million instance variables? An instance variable to hold the thing at index 0, an instance variable to hold the thing at index 1? Doesn't seem likely. Now, you might say we should an array list inside of MyList. which have an instance variable which is an array list, and it can keep track of the values for us. But remember, the exercise is pretending array list doesn't exist. So, given all those constraints and expectations, what should we have inside a MyList object to keep track? How can we keep track of all the things that might be added to a list? Yep.
A regular array?
He said a regular array. So let's think about that. Suppose we had an instance variable which was just an array of ints. And we'll just say, as things are added to the list, we'll store them in the array. When we have to go find out was it index 5, we'll just go look at index 5 of the array that we contain inside. Right? The array is inaccessible outside. When we've got to change the value in the list, we'll change the value in the array. When we've got to compute the size of the list, we'll just return the list of the array. Is that going to work? To store a list directly inside each object, an array inside each list object? Yeah? Okay. So what he's saying is, the problem is, that sounds good, but arrays are fixed length. So what's going to happen when we got to add something and the array is full? There is no way to make an array bigger, yeah?
Couldn't you just make a new array that's a copy of the same array, but it's one bigger with a new element?
Okay, what he said is exactly right. When our array fills up, we'll just make one that's bigger and copy everything over. Throw the old array away.
One bigger.
Yeah. Okay. We'll talk about how much bigger to make it. So here is my only instance variable. And that comment's very important because it explains our strategy. So we're going to have an array called data that holds ints. And it says holds the elements of the list, is exactly the same length as the list, and element I of the list is stored in element I of the array. That seems pretty straightforward. What we're going to do is we're going to make a list object that can grow arbitrarily. Inside of it will be an array that can't grow arbitrarily. Still, from the outside world standpoint, it's going to grow. So what's the constructor need to do to make this work? It says creates an empty list. Well, what should data be to represent an empty list? What does that comment up there tell you? This is our plan. What array will we represent an empty list with? Go ahead.
An array of lists of length 0.
Right, an empty, it says, is exactly the same length as the list. So if we're creating an empty list, we're going to create it, internally we're going to have an empty array. Okay? So there, that's the constructor. Let's try the constructor out. So right here, I'm going to create two lists, list 1 and list 2. So let me run it here. And here list 1 and list 2 have been constructed, so let's zoom in. What are we going to find when we cut list 1 open? When we look inside list 1 in the debugger? Remember, it's going to show us the instance variables. What are we going to see? Yeah? Yeah. An int array called data. So there's data, and you can see I just clicked on it. It's actually an empty array. Okay? List 2 will contain a different array called data. Empty as well. Okay? So far, so good. We were able to create empty lists. All right, now, I don't know how I got there. What about this one here? It says, returns the element at the specified index. If the index is invalid, throws an array index out of bounds exception. So remember, we've got, internally, we have an array that contains all the elements in the list. So if we're asked for element index, where is that going to be stored? What if we're asked for element 0 of the list? Yeah?
Well, at the very beginning, you said I goes to I, so whoever the index that you want out of the array,
Okay.
it's gonna be the same thing.
Right. So if our list is of length 10, our internal array will be of length 10. And if we want the element at index 0 of the list, it'll be stored at index 0 of the array, right? So why don't we just return data? Let's do that. Does that satisfy the specification? Why not?
Oh, wait a minute. It would grow.
Now you may be wondering, how did the array get bigger than empty? Right? Well, we got to take care of that down here when we're doing adding. But assuming we do add correctly, our array will be as big as we need it to be. And if we're asked for the thing at index 5 of the list, we're going to return the thing at index 5 of the array. So that looks like that works. What about the exception? What if it's a bad index? Suppose we give a negative index, or an index that's too big. Are we throwing an array index out of bounds exception? What do you think? Do I need to add a throw here? Yeah?
Well, if you look at the array itself, what does it do if I give it an index out of
Okay.
bounds?
If you give data a bad index, it throws an array index out of bounds exception. So it's being thrown for us, because we're ensuring our array is exactly the right size. Well, let's look at add. So we're asked to add an element to the end of this list, which means we got to take the array that we have and stick another element on the end of it somehow. We can't do that. The best we can do is make a copy of the existing array that's one bigger, copy everything over, and then add the new element. Now fortunately, there's a method, arrays.copyof, and you give it an array, and you give it the length you want the new array to have, and it returns a new array that's a copy of the old array plus extra space. How big do we want the new one to be? We've got to make room for one more element. Maybe our array right now contains 10 elements. We've got to add an 11th element. Yeah?
Data dot length plus 1.
Right. We need a new array that's one bigger than the old array. Okay? So that will copy everything from this array into a new array, plus there'll be an extra space at the end. Now, what do we do with that array? Why are we creating an array that's one bigger? Yeah? A little louder.
So we can add a new value.
So we can add the new value. Where should we store this array? Yeah? Right. It's the new value of our instance variable. So we're changing the instance variable so that it's the new bigger array. And then finally, we got to store val somewhere in this new array. Where should we store it? At what index should we store this element that we're trying to add to the list? Yeah?
Data length minus 1.
Right, at the end of the list. So data.length minus 1. We store it at the very end of the array. So every time add is called, there's a copy made. We have a new array that's one bigger stored in data. All that stuff is happening. The external user isn't aware of it. They're just saying add, get, set, add, size, and so on. All right, we'll continue with this example next time.